VLSos here. This is a video lesson introducing the idea of cusps and corners, which are features of functions, though they are uncommon features. To get an idea, we're first going to sketch a piecewise function to visualize cusps and corners. Cusps and corners at this level of calculus are interchangeable terms. You could call it either one. There is a subtle distinction between the two that of questionable importance in higher mathematics and later in calculus, but we will not visit the difference between what we call a cusp or a corner in this class. Here I have a few important places in the domain because they are the locations of these interesting features in this unusual function. We have cusps and corners at A, B, C, and D, but not E. And the locations which we would call corners are A, B, and D. And for a very subtle distinction that is not important, C, many people would call a cusp. From now on, I'm going to call all of these locations by the term corner. What's happening at these corners? Note that at every place that there is a corner, we have continuity. Drawing this piecewise function, even though I have to take a sharp turn at these corners at A, B, C, and D, it's still continuous at those locations. I have to lift my pencil and keep drawing E. E is not a corner. So what makes a corner different than any other part of the function? The corner is a location that is not linearizable. Meaning, if we were able to zoom in on any part of a curve, no matter how curved it is, if it's continuous and curved, we can zoom in and keep zooming in until that curvature looks more and more like a line. And in fact, everywhere where a function is curved, it's linearizable, meaning a line approximates the curve, except for corners. If we were to zoom in at any one of these corners, we would keep on zooming in and the feature of the corner would not change. It would continue to look like a sharp, angular distinction between the two pieces to the right or left. So a corner is a location that is not linearizable. What kind of functions have corners? The parent function that we are used to, and when we see it in our mathematics, it is almost always part of the magnitude function, or y is equal to the absolute value of x. This parent function has a corner at the origin. Many people in mathematics believe that the magnitude function ought not to be included in the family of parent functions because the magnitude function can be expressed as the piecewise function x for x greater than or equal to 0 and negative x for all x less than 0. So the magnitude function can be expressed as a piecewise. Some people believe that the magnitude function shouldn't be a parent function, which means that functions that have corners are almost always piecewise functions. And the corners almost always are at transition locations or transition points, where we transition from one piece to another. Very soon in calculus, We will, with a little bit more introduction as to what the derivative is and how we use it, it's at cusps and corners where we will not have a derivative. So finding and locating and justifying locations where a function has a corner becomes important, because at those locations we will not have a derivative, which is an important thing to know about the behavior of a function. The derivative is the same thing as the slope of the tangent line to a curve at any point, or from pre-calculus what we call the instantaneous rate of change of a function at any point.